Okay, I'm sure that this is going to come back and bite us in the backside a little bit later on in Skills Canada. But to get through like 95% of the competition, I think we can continually reset our encoders. And if not, then you know, we can always revamp it later on. Okay, so that's reset encoders. The next thing we want to do if we're going to go forwards is start using that set motor targets thing. All right, so the one thing that I want to make note of here is that we have two very special numbers. Now, one of them, I was playing around with one of my students and came up with the fact that if you want the wheel to move 1 centimeter, you have to tell the computer to move the motor until it's counted 45 ticks. All right, so 1 centimeter here equals 45 ticks. All right, that's pretty easy, but that also depends, by the way, on the size of the wheels. So if your wheels happen to change size, then we have a bit of a problem, because what happens? If the wheels change size, then this 45 tick thing might not work as well, or we may find that it goes down to like 44 or 45 and a half or something like that. Okay, so there might be a bit of an issue there. All right, and the other thing I noticed is that when you're asking the robot to turn left or right, okay, it would appear as if 1 degree, okay, equals roughly 14 ticks. All right, so for example here, if you want the robot to turn to the left, I have to get by a single degree, I need my left motor going backwards by 14 ticks and my right motor going forwards by 14 ticks. All right, and that's important because these two numbers are going to crop up all over the place. So I'm just going to leave them down here at the bottom where we can continually refer to them as things move along. Now, one other thing, you might find that the video cuts out and then starts up again. It's just because I refuse to verify my streaming account, so I'm just going to cut it off at 10 or 15 minutes, and you can just press on the next part of the video. So the next thing we're going to do is, we've already reset the encoders here. We're going to use a function that my students and I played around with a little bit yesterday, which is set motor targets. Okay, make sure I spell that properly, like so. And inside here, it takes two separate arguments. All right, it takes, and I'm just going to type these out, but of course, we're going to change it in a moment, but it's going to take speed 1, all right, and distance 1. That's for the first motor. And then the second is it takes speed 2 and distance 2. All right, and speed and distance 1 and 2 both refer to the first and the second motor. All right, now the one thing I'm going to tell you right now is you want to make sure that you're not getting your motors mixed up here, because often if you don't automatically just say that by default motor 1 is the one on the left, motor 2 is the one on the right, you're going to find that the robot's going to start doing, shall we say, odd things. All right, it's going to go left when it really is supposed to go right and stuff like that, because you'll have gotten that mixed up. So we're just automatically going to say motor 1 is left, motor 2 is right. All right, and that's from the point of view of standing behind the robot, watching it move forwards. All right, because of course, if I'm standing in front of the robot watching it move forwards, then my left and right are going to get mixed up. So imagine that you're sitting behind the robot, out of the way, you know, watching it move forwards. That's the left motor. The other one's the right motor. Okay, now, it actually turns out here that, you know, I have no variables named speed 1, distance 1, speed 2, and distance 2, but I do have speeds and distances. All right, so when you use this function and I want to put in, say, I want it to go forwards by 90 centimeters, I would actually put 90 here. and which means that this dist would turn into 90, and then this distance would go here and here, that would be 90. All right, so to show the computer that, I use this name in my function. So instead of saying distance1 and distance2, I just use dist. And that's just so that when this is 90, this is 90. When this is 80, this is 80. All right, and my speed I'm going to put right here. Okay, nice and simple. All right, now the other cool part is that I can just reuse this function. Now here, if I'm going to go backwards by centimeters, I have a distance and a speed. Now, normally, if I were to think physicsy, I would say that backwards is negative, but we're not going to worry about that here. If I want to go backwards by 90 centimeters, I just put in 90. All right. The place where I get the motor to move backwards is actually going to end up being right here, where I put negatives in. All right. And I do have to do one other thing here, which is that if I put a 90 in here, this is only going to move 90 ticks. Remembering that if I want this to go 90 centimeters, I have to multiply it by 45 so that this is converted into ticks. So I need to put in a times 45 and a times 45. And I need to do the same thing here for the backwards. All right. And again, the negative number here in the motor targets, all that means is go backwards by this times this many ticks. All right. Pretty simple stuff. All right. At least things that you have done before, I strongly suspect. Next, I need to go a turn by left. And to get the robot to turn left, of course, I need the left motor to turn backwards, the right motor to turn forwards, so I get rid of my minus sign. And of course, we're no longer dealing with distance here, we're dealing with degrees. So instead of using 45 here like I've got written, I need to use 14. So I'm going to change this over to 14, and I'm going to change this over to 14, like so. And the last thing I need to do here is I'm going to take this line, and I am going to put it into my turn right by degrees. But the thing I have to do now is just switch the minus sign from the left motor, which now goes forwards, to the right motor, which now goes backwards. And here, you'll notice that the robot turns right. Okay. There is one other little problem, and this is something that I honestly don't know the answer to. And hopefully by the time I get a chance to make too many more videos about this sort of stuff, I'll finally figure out what the problem is. But it turns out that because often the set motor targets takes a while to accomplish its task, all right, I often have to put delays into my functions, all right, and we've been putting them up here where we go forwards by this many centimeters, and normally I'd put a delay in here, you know, like 10,000 seconds or something like this. But the problem is that this 10,000 seconds, I really don't know how long it's going to take forward by centimeters to accomplish this task. I could be waiting down here for a while. All right, so I've come up with a formula, and you can experiment around with this a little bit. But the delay should depend on both the speed and the distance of the motor. All right. So for example, you know, if I have to move a distance of 90 and 91. Good grief, not paying attention. So if I have to move a distance of 90, I'm going to multiply that by 45 ticks. All right. Then I am going to divide this by my speed, and that should give me a time, or the amount of time it should take the motor to actually carry out this task. So when I go 90 times 45, and then I go divide by 180, I end up with about 22.5 seconds, which I have to say in practice is a really, really, really long period of time here. So basically what I've been doing is using a formula that's a little bit different. So I've been saying here that I want a delay of, and just like I did before, it's going to be my distance times 45 divided by my speed, like so. All right. Just to make the action a touch longer, I'm just going to put a +1 in here. All right. And I'm going to take the whole thing, because this is in seconds. Delay is actually in milliseconds, so we have to multiply the whole thing by 1,000. All right, so you take 1,000 multiplied by distance times 45 divided by speed plus 1, just like it is here. And while this is a little bit confusing, it's basically just a distance divided by speed equals time problem. Okay, stuff you might remember from grade 10. Now, this often causes a delay that's a little bit too large. So I've knocked this back to, instead of 1,000, to about 500. And this seems to work okay in practice. It's better than putting 20 seconds in between all of my function calls. And at least this way, if I'm only going a short distance, I only have a short delay. Okay, so this seems to work well in practice. All I can say here is that if you find the robot is acting funny for some reason, you can actually take a look, and if it's not going forwards by enough, it means that the delay isn't big enough here, and the computer is already starting to execute the second command before the first one has finished, and then it just stops the first command and automatically begins the second one. All right, so if you find that this delay isn't big enough, you can make this number here a bit larger. All right, and you can experiment around with that 600 or 700 or something. Usually, like I say, if there's some sort of odd behavior in your robot, then it's probably because the delay isn't big enough. So you want to make those numbers a bit larger, and if it's still acting funny, then you can always make it a bit larger. But eventually, if it's still if it's still really, really long and your robot's just sort of sitting still more than it is moving or something, you may actually have another bug somewhere. All right, but in practice, this seems to work quite well. So this basically now is 4 functions that allow us to go forwards, backward, turn left, and turn right. And now we're going to take a look at how to use them briefly. Now, up here, remember that we said forwards, and we said the first number will be a distance, the second number is the speed. All right? But when we write and use these functions in the program, I just write them out like this. I don't have to put the void in like I did down here. But instead of putting in dist for distance, let's say, I actually put the number of centimeters I want the thing to move forwards by. All right? And so, for example, here, I have 90 centimeters forwards, 90 centimeters backwards, and I don't know, let's keep doing this. 90 centimeters to the left, and 90 centimeters to the right, like so. And then speed, on the other hand, okay, and again, it's whatever you need this to be, okay? So like if you need this to go forwards by 2 meters or something, that's 200 centimeters, all right? So the next part is the speed, okay? And basically, it works like this. 360 equals 1 wheel rotation per second, okay? And so, 180, for example, equals a half a wheel rotation per second, okay? Like it's, nothing big, okay? Again, if you're not sure of the math, just use a calculator for this. If you want it twice as fast, like 2 wheel rotations per second, then you can go, 2 times 360 or 720, and that equals 2 wheel rotations per second. Okay, and that basically just tells you speeds on this stuff.